Alright, so now we're ready to start taking a bit of a deeper dive look at IP addressing, and we're going to start off taking a look at IP version 4. And we're going to take a look at not only IP version 4, but also IP version 6. But a majority of our time is going to be spent taking a look at IP version 4 for a couple of reasons. Number one, even though IPv6 has been around for quite some time, IPv4 still seems to be fairly dominant within a lot of local area networks. Also, a lot of the fundamental IT certifications, they require you to understand on a fairly deep level IP version 4 addresses. So talking about the anatomy, understanding the different classes, being able to subnet IP version 4 addresses. So because a lot of you that take this course are interested in moving forward into the IT field, I want to make sure you have a basic understanding of IP version 4. Now, additionally, IP version 6 is a bit more of an advanced topic, so you're really not going to have to fully understand exactly how it works on a deep level unless you decide to become a network engineer and you go down the route of Cisco or Juniper certifications. So for that reason, we're just going to do a basic introductory look at IP version 6. Okay, with that said, let's start off doing a bit of a refresher. So we already know that IP addresses are logical addresses that we assign either manually or dynamically with DHCP, and that they operate at the network layer. Additionally, we know that IP addresses uniquely identify a device on an IP-based network. Pretty basic stuff, right? So let's go ahead and let's take a bit of a deeper dive look. So here's a breakdown of an IP version 4 address, and we'll talk about this as we go through this. So number one, it is made up of 32 binary bits. So we look at an IP address in what we call the dotted decimal format that you see right here. This is what we use it for on our systems, for our brains, for us to be able to understand it. We say, okay, well, I see an IP address and it's, for example, 192.168.1.131. But our computer, it converts it into binary. And so binary is going to be this. So it sees it as ones and zeros, whereas we see it as a dotted decimal format, 192.168.1.131, for example. In addition to that, and let me get rid of all this highlighting. In addition to that, an IP address has two different sections. So an IP address is broken up into a network portion and a host portion. And I'm not going to really talk about that now too much because I have a very simple example to talk about it. But very basically, there's a portion that identifies the network that it's on, and there's a portion of the address that identifies the host portion, the host addresses. And to determine this, we use something called a subnet mask. So the IP address combined with the subnet mask will tell us, it'll tell us what portion is the network portion and what portion is the host portion. And you'll understand all this as we progress through the numerous lectures on IP version 4 addressing in the following sections. Now, in terms of basic terminology, there are multiple different ways in which we can express the different 32 binary bits here. So they're broken into 4 octets. So we call these, each area that's separated by a dot, we call this an octet. So for example, right here, I'll put a box around it. This is an octet. And the reason it's called an octet is because each octet has 8 bits. So 1, 2, 3, 4, 5, 6, 7, 8. So each one of these have 8 bits. Now, a bit is also equal to a byte, but you typically hear people call them an octet. So 32 bits can equal 4 bytes or it can equal 4 octets. So that's the basic anatomy of these addresses. And in terms of understanding the binary portion of that, don't worry, we're actually going to walk through the process of doing the conversion from a decimal format to a binary format and going back the other way from binary to decimal later in the course. So let's take another deep dive look at this as well. So what I wanted to do on the screen is I broke it out and I showed you the different octets. So we have the address up here, 192.168.1.131. What we've done down here is I've broken out the different octets from the first octet all the way to the fourth octet. And what I've done is shown the address in the decimal number, the binary number, and how many bits there are for each octet. So I just wanted to show it in this format as well. And you're going to become very familiar with these different formats as we progress in the multiple lectures on IPv4 addressing. Alright, so now let's talk about that network portion and that host portion I was talking about. So this is a very simple example that I like to use. So we have the network address portion and we have the host address portion of an IPv4 address. So a very simple way to look at this is to think about a street address. So for example, let's say that we have a street address of 7682 Wilshire Drive. Well, with this address here, it's broken up into two different portions, right? We can think of the street as the network, and we can think of the houses on the street that each have their own number. We can think of that as the host. And so if we think about an IP address from that perspective, we understand that there is a network portion and a host portion. So the network portion, and let me get rid of this highlighting, the network portion here shown in orange, the Wilshire Drive, that identifies the network that we're on, or for example, the street that we're on. But for each individual house, if we think of each individual house on that street as a computer with an IP address, it's the number that identifies that uniquely identifies that house or that computer on that network. So when we look at an IPv4 address, we need to understand that when we see, for example, 192.168.0.106, when we're looking at that combined with the subnet mask, and I'll show you how all that works later in future videos, we can determine what portion of that address is the network portion, and we can determine what portion is the host portion, where we can give out these addresses to the different devices on our network. And so I wanted to use this as a basic example to help you to understand that when you see an IPv4 address, there's a network portion and a host portion, and that equals an IP address. And it's going to be in this format, even though I used the example of a street, it's going to be in this format where we have the network portion first and the host portion second. But utilizing this example of an address for a street is really a very simplistic way and an easy way to help you to understand how this works. Okay, let's take a look at one more slide, and let's talk about the different types of addresses that you're going to see assigned to a system. So for a device on a network, you're typically going to see an IP address, you're going to see a subnet mask, and if we need internet access, you're going to see a default gateway. So again, the IP address, we've already talked about this. This is the unique logical address that's assigned to each device on the network. But you cannot have an IP address without a subnet mask, because we use the subnet mask to determine what subnet, and a subnet is just another way of saying a network, to determine what network the actual computer or device is on. So we always have to have an IP address plus a subnet mask when we're talking about IPv4 addresses. Now, the optional part is the default gateway. So the default gateway is the router's IP address that allows a device to communicate outside of its local subnet. And again, in other words, a subnet is a network. So if we determine that the devices on our network need to communicate out to another network or on the internet, we need to provide it a default gateway. Now, this is optional because let's say, for example, we're in a top secret network and we don't want it to access any external network. It's just devices connected together and they don't connect to anything else. Then we would exclude the default gateway. So a lot of people always ask me, well, Alden, what do we do if there's no internet access? Or how does the network work if there's no internet access? Well, we don't need internet access, or we don't need access to other networks in every implementation of a network. This is optional. It all depends on the purpose of the network, the business or organizational purpose, and also the scope of the network as well, determining if it needs to connect to another network. So that's the three different components of a device's setup when we're setting up an IPv4 address. And here's an example right here. So we have the three different addresses right here. We have the IPv4 address, we have the subnet mask address, and we have the default gateway address. And also in this example, we see an IPv6 address right here. And these, like I said, can be quite complex, so we're not going to take that much of a deep dive look at them. We're just going to do the fundamentals. So anyways, that's going to conclude our introductory lecture to IPv4 addresses. If you have any questions, please let me know. If not, thanks for watching, and I'll see you at the next lecture. Take care.